I think we've got everybody back, right? Good. Okay. What we're going to do is we're going to jump in, close out lecture today with just basic fundamentals. Just going to be a refresher. Will be review for most of you, but we'll just go through, make sure we're on the same board before we jump into other stuff. So, overview of stuff we're going to work on today. Just review basic purpose, what we're trying to do with some of these statistical analyses, and then going to go through just basic terms so that if I say population, you know what I'm talking about, things like that. So, purpose of statistics, like always, it's nice before we jump in to do something, try and keep in mind what are we trying to accomplish with this, what are we trying to do, right? One of the big things we're trying to do with our analyses, either descriptive or inferential, trying to organize quantities of information in a way that's going to be meaningful to other people, right? When we're working with sets, and we're, in the context of psychology, we're actually working with quite small sets relative to other fields, right? But even if I give you a data set like this, and I say, and I want to know how much it is this group of students drink, and I give you drinks per month, what do you say? Like, are these students drinking a lot, or are they drinking a little? What are people's thoughts? Katie, what do you think? Are these people drinking a lot or a little? A little? Okay. It starts to become difficult, right? Like, this is not that many numbers, but to try and sort of condense that and just eyeball it and say, oh, is this a lot or a little? Also depends on what we're calling a lot or a little, right? Operationalization of our construct starts to become a big issue with this, right? And so, my head's probably getting away to that. But what we can do is we can start to run some descriptive statistics with this and start to get a general overall feel for how much this sample of individuals are drinking, right? So here, we can run the mean on all of this, and we get a mean of 14.5 drinks per month. Who does alcohol? Who's working with Allison? Yeah, Lauren, is this a lot or a little bit drinking? Depends. We're talking about 8-year-olds, probably a lot. Right. Adults, maybe not. Drink every other day, not terrible, right? We notice our standard deviation's pretty big, right? What does that tell us, Angelique?
They're varying from the mean.
Yeah, right. So we've got quite a bit of variation in this set, right? So on average, people are having about a drink every couple of days, but some reasonable variability around that that point estimate, and our range is quite large on this, right? So by going through and running some basic descriptive statistics, we can start to get a general sense, right? But we might also want to plot this out, right? Figures and graphs are oftentimes far more effective ways of communicating information than summary statistics, right? I can say, you can tell me 15.5 drinks per month, but if you plot out these data, I start to get a better sense of what is actually going on, right? And so 15.5 drinks a month, some variability in there, but this does a lot better job of saying what's actually going on within this data set. Stephanie, talk to me. What do you see going on in this histogram here?
I would say that those who are drinking within like 45 or 40 to 45 drinks are probably outliers. The majority are between 0 to 30 drinks. The mean might not be the best indicator of the...
Yeah, why is that?
Because the data is skewed.
And what's that going to do to my mean?
It's going to move it, it's going to make it higher than what it should be.
It's going to drag it out, right? This person drinking 60 some odd drinks, where are they at in here? Someone's hitting the sauce pretty heavy. I don't know where they're set, right? But they're dragging the mean out, right? Another thing, if I'm taking a look at this, right, I might start to say I might have a couple of different populations going on here, right? I've got probably a group of people who drink very infrequently, and maybe some people who drink more casually here, and then some people who are drinking quite heavily, right? Depending on my research question, that might be an important thing to know, is maybe I don't have one sample or maybe I'm not sampling from one population, I'm actually sampling from a couple of different populations. I can't tell that though with just the descriptive statistics, right? So thinking about looking at our data from a number of different ways and not just relying on, oh, this is my statistic that tells me everything about everything in order to get a complete picture of what's going on, okay? Also, our statistical analysis, this typically what we think about, gives us an objective assessment of the relation between two different variables, right? So let's say I have a sample of 334 individuals been exposed to traumatic injury, 248 reported chronic pain within the past 12 months post-accident, okay? So got a sample, pretty sizable proportion of that sample are individuals who are experiencing chronic pain. What I'm interested in doing is looking at the degree to which chronic pain status is related to some measure of trait anxiety, right? Are people's state level of anxiety related in some way to whether or not they're reporting chronic pain or not? Someone tell me how, with the statistical analyses, how I might go about answering this question. What are some options? Sam, any ideas on how I might approach a statistical test to take a look at this?
Correlation.
Absolutely right. I could do a correlation, right? I can do that. What else? What other tests might this lend itself well to? So I've got people with chronic pain, without chronic pain, and I'm interested in whether or not how that relates to trait anxiety. T-test, right? And maybe what I do is I run a t-test here, right? And I run this analysis and I find that yes, in fact, pain status, whether or not people, participants do or don't have chronic pain, does hold a reliable relationship with trait anxiety. In this case, what I'm doing is I'm looking at whether or not mean levels of reported anxiety are higher in the individuals who are reporting chronic pain versus those who don't. I run my t-test, I see that it's statistically reliable within our conventional standards. I might run an effect size here and say, because my sample's pretty large, see what's the magnitude of this this difference. My effect size here is going to tell me that almost the people who are reporting chronic pain are reporting almost a half a standard deviation higher levels of pain on whatever my pain measure is relative to people without pain. I could also look at the mean difference, right? And then calculate a confidence interval around this. We're going to be doing a lot of this stuff, right? I might say, on average, we're seeing that people with chronic pain are reporting close to 6 points higher on average on this scale. But this is just a sample, and that difference could fall anywhere from about 2.5 to 9 points in the population of individuals with chronic pain and without, right? So a number of different ways we can go through and start to quantify, not only do we see a reliable relation, but how big is this relation, and then how we might go through and start determining whether or not this is something that's clinically, theoretically interesting from a research perspective. But as Sam said, we could also go through and run a correlation on this. That's perfectly fine. We've got a dichotomous variable, whether or not people have chronic pain or not, and then we've got a continuous outcome, whether or not or scores on our chronic pain measure. Fair enough, we can run a correlation on this. It's actually equivalent to our t-test, right? Because when we're working with a dichotomous variable, our scatter plot doesn't look all that great. But if we run a regression line through this, it's going to go somewhere right along there. We see that our effect size for our correlation looks like it's a moderate effect size. And again, we can calculate a confidence interval around that, saying in our sample, our point estimate is 0.4 for that correlation, but within the population, anything between 0.3 and 0.48 looks like it'd be a reasonable guess for the relation between chronic pain status and anxiety as we've measured it within this study, okay? So again, a lot of different ways we can go about starting to talk about, understand, even very simple things like, is X related to Y? Okay. Questions about this? All right. Other thing it does is it gives us a standard language for professional communication, right? If I'm communicating with Dr. Perry at Cambridge University about something, it's nice, there you go, right? High hopes. It's nice if I can say, hey, this is what I found, and Candace knows what I'm talking about based on the information that I've given her, right? But this is one of the things where at a graduate level, for you, my hope is that you can start understanding these types of analyses at a higher level than just saying, yeah, X is related to Y, right? This Wilkinson article is, you'll find out, is one of my favorite articles. These articles that are assigned for this week are very, very good. I'm going to keep going back to them. Basically, it lays out all of the things that we should be doing that we never do, okay? My hope is to beat this into you over the course of 2 semesters so that it's sort of second nature, that you start thinking about these things. But what typically happens is we learn what we should do in class, and then we go out and do it and hit our own research, and then we don't do it. You'll find that we've been talking about these are the things that we should do since the 20s and 30s, and we still haven't got there yet. Again, so with repetition, my goal is to get you so that this thinking about these types of things is second nature. But some quotes from Wilkinson, right? More important than choosing a statistical package is verifying your results, understanding what they mean, and knowing how they're computed. Lots of times people get worked up about, oh, how do I get this number? What menu do I choose? X, Y, and Z. I can teach a pigeon to punch keys. I can't teach a pigeon to understand and provide some sort of conceptual understanding of what these data mean, right? Do not report statistics found on a printout without understanding how they're computed or what they mean, right? 1, this is just scientifically responsible. 2, it's going to help you not look like a moron, right? If you, not that you would all look like morons, but sometimes people say, oh, this, and if you understand what's going on back, well, that's clearly not correct because that's an impossible number. Like, that makes no sense within the context of what you've done. But unless you know that, right, and you report, you know, a t-statistic of 10,000, I don't know how you got that, but that's clearly not a real value. It sort of puts you in a position where people start to question whether or not your whole research project is on shaky ground. And so we're going to go through and make sure that you know what you're reporting, why you're reporting it, how you calculated it, and what some of that stuff means, okay? We should never, never, never advocate all of our knowledge into the statistical machine and just print out mindlessly whatever it gives us. SPSS will give you numbers with whatever you ask for, but what you're asking for might not make any sense, okay? And again, taking efforts to understand underlying assumptions of analyses, whether or not these are reasonable for a data, right? Gas engine works perfectly well if you put gas in it. If I dump a bunch of diesel in there, it might run, but it's not going to run very well. And dump some kerosene in there, I don't know, it might start up, might blow it up, who knows, right? Like, SPSS will do whatever you ask it to do, but oftentimes our data aren't suitable for the types of analyses that we would want to do, and so then it becomes incumbent on us to go through, make sure we understand where we have violations, whether or not that's a big deal or not. Sometimes it is, sometimes it's not, right? And then understanding the impact, right? We can do this, but if we do this, what's going to happen? Hopefully over the course of this semester, getting you in the seat of thinking of yourselves as statistical consultants, right? Some of you will maybe find yourselves doing this type of work, and what happens is you have people saying, I want to do this. And you say, well, understand that you want to do this. This is why I advise you not to do this, because what you're going to get is nothing that's reasonably interpreted based on what you've got, right? This will be helpful if you're ever in a statistical consultation role, but also in your own research, being able to say, well, this is a reasonable approach given what we've got with our data. Okay. So, and again, when you think of effects, think of credibility, generalizability, and robustness, right? Not all of our studies generalize to all possible scenarios, right? Sometimes we get effects that are way outside of the norm that are weird, right? If I went through and collected, it's possible I'm a trauma researcher, I might run a study and I find that severity of trauma exposure is related to lower levels of PTSD, right? And that might be what my data tells me. But I should know, based on my field, that that doesn't make sense, that there's something funky going on in these data. Now I need to do some detective work to figure out what went on with that, right? Same thing. We're not just saying, oh, well, that's what the data told us, right? Thinking about within the context of the research question, does this make sense? Is this effect likely to replicate? and who does this generalize to, right? We make a lot of, who is our typical sample for a psychology study? Undergraduates, right? So there are some things, and I fight with people about this, that go, well, it's an undergraduate sample. Well, the thing we're looking at doesn't matter, like, if I'm looking at basic reaction times or things along those lines, or some sort of biological process, I don't know that undergraduates have a different fundamental biological process than any other human out there in the universe, right? But sometimes there are things that we're looking at where, yeah, what's going on in the lives of undergraduates may not generalize well to the people that we're looking at. Important to start thinking about the data that we're running. What are the limitations, or what are the limits of generalizability? What can we say? What can we infer based on the data? But none of this is based on your statistical model, right? You're not going to get a data or a figure that says, oh, this is the extent to which this is going to replicate, or this is believable, or things along those lines. This is method stuff that you're going to have to be thinking about as you're moving forward with things. Okay? Questions about any of this? All right. Basic terms and concepts. Population versus sample. Population, this is a set of all individuals' units of interest. Important to recognize that populations are specific to study and can vary widely in size. Typically when we think about population, Rajiv, if I think about population, what am I thinking, big or small?
It's big.
Thinking about big, right?
Yeah,
right?
Kind of like the whole university students.
Right? Or all the people in the world, right? If I'm looking at human process, my population is humans, right? And that's a pretty big population, but it doesn't have to be. Someone give me other examples of what might be a population. So university students, right? And then we need to specify, are we talking about university students at the University of Wyoming? Or are we talking about all university
All
students?
universities.
Right? All university students at all universities just in America or across the country, right? Starts to become tricky to think about who is my population. Give me another example of a population. Yes, Sam.
Asians in the United States.
Asians in the United States, right? I'm interested in some cultural aspect of Asian Americans, and so my population is Asian Americans in the United States, right? Someone else give me another example of population.
Active duty military.
Active duty military, right? So all the people, let's say, of U.S. military who are involved in actively on deployment or something along those lines, right? So these are big populations, but populations can also be hypothetical, right? Let's say I have a treatment, and I want to see if my treatment is effective. Who's my population? All people who could potentially receive this treatment, right? Now that's not a real, like, and maybe I've only provided this treatment to 5 people, but what I'm hoping to generalize is that this treatment, so my population is anybody who could hypothetically receive this treatment would be the population of interest. Same thing if I'm an experimental student. I'm trying to switch back and forth between clinical. I don't want all my examples to be clinical for experimental people, right? But I've got some sort of manipulation, right? My hypothetical population is all humans who could conceivably participate in this population, right? So it starts to get a little bit heady when we're starting to go through. But the one thing we want to do is always think about the population. Who are we trying to generalize this to? Who are we interested in? Because all humans in the United States, or all humans in the world, may not be the population of interest, right? And so, again, within the APA task force, interpretation of any results of the study depends on characteristics of population intended for analyses, right? So if I'm doing a project, and I am right now looking at prevalence of trauma exposure, and I've just captured undergraduates, I can talk about the prevalence of exposure in undergraduates at the University of Wyoming. I don't know if that generalizes to all undergraduates in the United States, but I would certainly be careful about saying, oh, this is the prevalence of sexual assault in the U.S. population if I've only got this subsegment of the population that I've sampled from, right? So important to start thinking about these. I will beat you over the head asking you what your population of interest is in these sets. This will come up again and again, but it starts to become tricky, so I want you guys to be thinking like that, okay? So in contrast with our population, what we're generally working with are sample population of interest. Hopefully, sometimes this is our population of interest and we go sample people from a different population, which is problematic, right? and then pretend like we didn't do it. Important is keep this in mind, but this is sort of our group of people that we're going to be working with. All right, Lauren, why don't we just work with population? It seems like that'd be easier, right?
It's not possible.
It's generally not possible, right? Like I can't get access to even sort of our, as close as we can get, like with epidemiological, we're still not getting access to the whole population, right? And so what we're going to do is we're going to select, say these are the people I'm interested in. I can't get a hold of all those people, so I'm going to select a sample of people, right? Hopefully, we're going to get a random sample. This is our gold standard. What does it mean if we've collected a random sample? Morgan?
Ideally, it'd be representative of the entire population.
Ideally, it would be representative of the population. Can I get a random sample that's not representative? Yeah. Right. What's the key feature of a random sample? What am I trying to get?
Diversity? Diversity?
Hopefully. Well, what about a random sample makes it a random sample? What's it? A little circular? Yeah.
You're including like the whole population, like
Oh.
when you're selecting.
Right. And what else?
Everyone has equal
Everyone has an
opportunity.
equal chance, right? Everybody in this population has an equal chance of being selected, right? It doesn't matter where they live, what they're doing, what their characteristics are. Every single person in the population has an equal likelihood of being selected. Do we work with random samples? No. I mean, we just don't. This is kind of a hypothetical construct, but the best thing that we can do in psychological research is get the best sample that we can and hopefully get a sample that's large. When we're talking about samples bigger is better, why is this? What's that? It increases our power from a statistical standpoint, and it increases the likelihood we're going to detect stuff, right? From a conceptual standpoint, why are bigger samples better? Yeah,
So
Sam.
everything like evens out as more, like you get more like people.
Has to do with precision, right? The bigger the sample I get means the larger proportion of the population I'm capturing, even if it's on the margins, right? I'm likely to get a more representative sample the bigger the sample is, all else things being equal, right? If I got a sample of 10 people, even if it's random, it could be wicked biased, right? But if I've got a sample of 1,000 people, the precision of my point estimates is going to be much, much better because I've got a larger group of individuals. And so in general, we're going to try to do the best that we can, both in terms of representativeness and in the power of our statistical tests. And we'll talk about power and all the ins and outs of that in a later lecture. So again, thinking about this, here's the population. This is everybody that we're interested in, right? We can't get at everybody we're interested in, and so we get a sample, right? Sample is who we can test. Best case scenario, we've selected a large random sample from the population, but if we're being honest about how we collect our samples, what are our samples? Most generally, how would we describe them? Convenience samples for the most part, right? And we don't like to talk about this, right? But it's what happens, right? It just, the people who were captured in intro psych class who I managed to get in my study, intro psych is a big university class, we get lots of people from lots of other places, right? But our sample hopefully is some fair representation of our population. And then what we do with that sample is we run some statistics on that, right? We run our tests, we go through, look at our correlations, whatever our analysis is, and then what we want to do based on these statistics is make some inference about the population, right? This is who we're interested in. We can't get all of these people, so we get a subset of those people. We run some tests on that subset of people, and the goal is always to learn something, make some inference about some process phenomenon within the population, right? Our statistical procedures used to make inferences about the population based on data collected from a sample of those individuals. Our hypotheses are never about our sample. We have cruelly selected a bunch of people who we don't care about in order to learn something about the population. The sample is never the focus of interest, right? This is something else I'll beat you over the head again and again and again with when I'm having you tell me what our hypotheses are. Our hypotheses are always about the population because I really could care less about the 100 people in my sample in terms of what's going on there, right? Never in my lifetime will I say, oh, the 100 people in my sample are the only people I care about. For these 100 people in my sample, like, this is what's going on with them, and to hell with what's going on in the population, right? Our goal is always to learn something about the population. The sample is just a mechanism by which we can go through and start to draw some meaningful inferences about likely what's going on within the larger population of individuals, okay? We're gonna spend a lot of time writing out. I'm gonna ask you what the null hypothesis is, what the alternate hypothesis is, and what I want you to do is be stating those hypotheses within the context of the population, right? Hypothesis is that trait level of anxiety will hold some relation with chronic pain within the population of individuals exposed to traumatic injury, okay? In that situation, I've identified my constructs, I've identified what I think is gonna happen, and specified that what I think this process is relevant to the population of individuals who have been exposed to traumatic injury as we've defined it within the context of this study, okay? This forces you to start thinking about my research question, who I think it should generalize to, and is a more difficult thing than saying there is no difference in the sample or so on and so forth. We'll talk about this, but again, something I'm gonna hit you guys with and make sure that you're sort of thinking about this in terms of population-based stuff, okay? Does all this stuff make sense? Any questions? All right. Variables. Variable, characteristic condition that changes, has different values, is different than a constant, right? If I grab a sample and all my sample is women, is gender a constant or a variable? It's constant in the sample, right? It's a variable because gender can differ, right, within the population, but within the context of my sample, this is a constant, right? And so if I try and run an analysis on it, it's going to give me things that I don't like, right? So as long as we have some variability, this is going to be a variable, but if all the values on everybody who we've collected are the exact same, we've got a constant. Sometimes we can have a variable that is pretty much a constant, right? So if I run a sample and 99.8% of my sample are white, non-Hispanic Caucasians, is ethnicity a variable? Not really, not one that I can use for anything, right? And so thinking about the variability in our data sets. Variability is a good thing in general. Variability helps us establish relations as long as it's not too far out of bounds. We start to run into problems if we don't get adequate differences in our data. I'm helping one of our graduate students run some consultation for a school district who's trying to determine whether or not some educational program is working. I can reach out to members of my community. I know how to handle it. If I have a friend it's like DARE with a bunch of other stuff, right? But what they did is they go through and they hand 7th and 11th graders a questionnaire that says, how confident are you that you can do anything? What do you think happened? 0, not at all confident. 7, 100% confident. What do you think that data looked like? 7s down the board, right? Is not useful, right? And particularly if that's your pretest, there's nowhere for you to go and determine, right? And so these are the types of things you want to go through and think about. Looking at your data, what did we get? Is this what we were anticipating? And then circling back now on the second go around with this consultation, trying to think about, okay, how do we rephrase questions so we can get some variability in our data? Because if I'm in 7th grade and think I know everything or don't care about this and just write 7s down the board, that doesn't help us out if we're trying to do any type of formal analysis on things. So we've got our variables. Parameter, this is characteristic that describes the population. These are hypotheticals. These are things that are unknown to us almost always. We typically indicate our parameter, population parameter with a Greek symbol. A statistic, this is a characteristic of the sample, okay? Arabic letters to denote our statistics. We work again with our statistics because our population parameters are unknown. What we want to know is this. These are either unknowable because of lack of resources or unknowable because they're just unknowable things. So we work with our statistics, and so in terms of our notation, differentiating between our Greek symbols with our parameters, our statistics with their Arabic numbers. Okay? Descriptive and inferential statistics, a couple of different approaches. Our descriptive statistics, these are our procedures that help summarize, organize, simplify our data, bring things down so that we can communicate. I want to say, Katie, this is what I've found in these data. Here's some descriptives, and give Katie a snapshot so she can understand kind of what the parameters of these data are doing. These are our averages, our tables, our graphs, things along those lines. Here we have a box and whisker plot. I'm going to be forcing you guys to tell me a lot about box and whisker plots. Box and whisker plots are nice because these tell us a lot of things about the distribution of our variables here. If we're looking at, what is this, absences across something. I don't know, I pulled this off of Google. But what this is telling us is across this variable, across years, we're getting, you know, some distributions on here in terms of range, in terms of median levels of absences. Looks like here in general our absences are increasing through year 11 and then kind of plateau out. But we get much more variability in absences as we move forward. Something's weird going on in 11. Here we got actually not a lot of variability, but more on the extremes, right? And so being able to take a look at different types of graphs and figures and be able to learn something about those, right? I could also present this as a bar graph and just give you mean values that has considerably less information than this box and whisker plot when I can start getting understand variability in the data set and things along those lines. Okay? These are our descriptive statistics, our inferential statistics. These are things with p-values attached to them. Okay? These are techniques that are going to allow us to take information that we derive from samples and start to go through and make some type of inference about a population based on some of the tests that we make. These are things like correlations, ANOVAs, t-tests. We'll be considering distributions, known and hypothetical, and trying to say, all right, given the distribution of this, assuming that the data fall out this way, we can say with this amount of confidence that sort of the population value should fall somewhere between this and this as reasonable guesses for what we have moving forward, right? These two things together can be very effective in communicating information and starting to know things. Again, purpose of statistics in general, this effort to move away from opinions, right? I have the opinion that play therapy is the best therapy out there. That's fine if I have that opinion, right? But from a scientific standpoint, I should be able to back that up with some sort of data, right? This is where we start to move away from opinions, what I think, to actually objectively what I can demonstrate based on however I've set up my experiment, right? These two things together help us start to provide evidence for or against our various hypotheses. Questions about that? Sampling error. All right, this is big. This is going to catch you and mess you up again and again and again. All right, sampling error. Sampling error is very, very simple from a conceptual standpoint. Okay, sampling error is just the discrepancy between a sample statistic and the population parameter. Okay, here's my population parameter out in the universe. Something I don't know what it is, but it's out there in a theoretical sense. And so what I do is I want to know what the population parameter is, and so I go through and I collect some data and I get a sample, okay? And I find, I'm interested in the average of the population, the mean of the population. That's what I want to know, right? I want to know, on average, how extroverted Americans are, right? So I'm doing some cultural stuff. Sort of American culture is what I'm interested in. So all adults in the United States are my population of interest. And so what I do is I capture a sample of Wyoming undergraduates as representative of the US population. And I go through and I calculate the mean level of extroversion in that sample, okay? The difference between the sample mean and the actual hypothetical unknowable population mean, that's my sampling error, okay? No more, no less. It doesn't necessarily, sampling error has no reflection on your sample. In this example, the sampling strategy is poor. But are we ever not going to have sampling error? we'll always have sampling error, right? Like, we'll always be off to some decimal place, right? What we want to do is try and minimize that sampling error. But at a fundamental level, all we're talking about in terms of sampling error is the discrepancy between the sample statistic and the population parameter. Questions conceptually about this? Yeah.
So you could eliminate sampling error by using the whole population.
Yes, but why do we not have to worry about sampling error if I've got the whole population?
Because you're actually finding out about the term.
If I have access to the population, do I need statistics? No, right? If I say, here's all the people with chronic pain, and here's all the people without chronic pain, and I say, here's the mean for all the people with chronic pain, and here's the mean without all the chronic people with chronic pain, do I need to run a statistical test to see if those are statistically different? Why not?
Because there is a difference.
Because exactly, there's a difference. They're not the same number, right? So if I'm working with population, I don't have to worry about statistics, right? Like it might not be a huge difference, but I can say this number is not the same as that number, therefore they are different, right? If I have access to the population, but generally we don't, right? And so I say, here's this number, or the mean of this sample, here's the mean of this sample. Are they different? I don't know. We're going to have some sampling in there, and that's where inferential statistics come in, where we can say, based on these data, it's unlikely that, assuming the null hypothesis is true, assuming that there is no difference between these two populations, it would be unlikely for us to get a difference of this magnitude or greater, right? And we'll talk about why that actually doesn't answer the question we'd like to know, but it's what our statistics do, right? So yes, if we had access to the population, that would eliminate sampling error, because we wouldn't need to collect a sample because we've got the population there to work with, right? And there are situations where we might be working with biomedical research, right? If you have a rare condition and there's like 7 people or rats in the entire universe that has this condition, that's your population, right? But it's rare within our types of, within social science research that you're going to be working with populations. Okay? So, we design, if we're thinking about sampling error, we design our sample to be representative of our population, but impossible for our sample to exactly match the population of interest, right? We are never going to get a sample that's dead on exactly the same as the characteristics of our population. We're always going to have some differences, right? So here, our population, and Rajiv, like you were saying, maybe our population is University of Wyoming students. And technically, if University of Wyoming students is the population, we might be able to get a population parameter on that if we were able to round up everybody who's a student at the University of Wyoming. But that's still going to be hard to do even with a limited population, right? So maybe what we do is we go through and we sample 1,000 of them. That's a pretty substantial sample, right? That's probably a quarter of all of our undergrad students, right? Rick, you know what our enrollment is?
It's about between 8 and 9 for undergrads, I think.
Okay, never mind. I thought it was I'm not a numbers guy.
20%, 25%.
Right. Yeah. So, but it's still going to be a big sample, right? And so what we do, and in this example, I guess we're looking at IQ. So we get average age, average IQ, and gender breakdown here, right? And these are our population parameters. But 2 samples of 1,000 randomly selected students. Somehow we figured out how to randomly select students to come in, give them an IQ test, measure their age and gender. 2 independent random samples. Sample 1. I guess not 1,000 people. This is our population. So 1,000 college students. Okay, now we've got very poor samples. Now we've got 5. So sample 1, 5 randomly selected individuals from the population of 1,000. Sample 2, another 5 individuals. Here we've got an age of 19.8, average IQ of 104.6, 60-40 female male. Here, age of 20.4, average IQ 114. Sample some smarties here. 40% female, 60% male. This is our sampling error, right? The difference between these statistics and these parameters Sampling error is not what happens when you get a poor sample. I mean, it is, but that's not what the definition of sampling error is. Sampling error is just the difference, the discrepancy between your population parameter and your sample statistic, right? What's the biggest drawback of our samples here?
Really small.
They're really, really small, right? If we were to collect 100 observations, what would happen to our sampling error? It would go down, right? So the things that we expect to impact our sampling error is our sample size. The larger the sample, the more, in general, all things being held equal, the more representative the population it is, unless you've got a really funky way of going about capturing your sample. In general, as we get more and more people, we're more and more likely to start to capture some of those people who are on the outskirts, right? If I get a sample of 5 people or 10 people from the 5 men, and so I'm interested in height of men on the University of Wyoming campus, right? And I go through and grab up 5 guys, 10 guys, yeah, pretty close probably, right? But who am I gonna miss if I just grab 10 guys? And I'm interested in height. What do you think, Morgan?
No. Because I'm feeling like you were going to either miss the average or the outliers.
Well, with a small sample, probably the outliers, right? In my random sample, I'm just hanging out on Prexy, right, or whatever the jam band thing they got going on. I just grab 10 random dudes, right? I'm probably going to miss, basketball players or guys who are just, taller than Rick and I, right? Rick and I are pretty tall, but like they're people who are much taller than us, right? But there are not many of them out there, right? We're going to miss those. Also, we're going to get people who are considerably shorter or smaller than the average, right? Because there's not that many people. We're going to get, it's not that we're going to be totally off, right? We're probably going to, in general, we're probably going to get something that's close to the mean, but we're going to start to miss those extremes. So we're going to underestimate the variability in our sample, okay? So sample size, as we start to collect more and more people, it's more and more likely we're going to start to get those margins on whatever characteristic it is that we're looking at. Sample selection also makes a difference, right? If I'm interested in adults in the U.S., what's probably my best sampling strategy? What do you think, Sam?
Adults in every state.
Yeah, right? Some sort of maybe random digit dialing, some epidemiological research, right, where I've got phone numbers, addresses, maybe from the U.S. Census to go through and try and go through and randomly select people in certain homes and go through and try and get a randomly selected sampling of people in the U.S. Right? But what we typically do is we typically say, these are the people in my intro psych class, right? One is going to give us much less sampling error than the other, right? If I'm only looking at undergraduates, how is that biasing the characteristics of my sample? What do you think, Katie? What are some things we're going to be off on in terms of if my interest is Americans?
Well, characteristics of undergrads can be people who choose not to go to college.
Okay, so people who obviously aren't in college, right? And what is that probably going to capture then in terms of thinking about characteristics of the U.S. population? How is my sample going to differ than the target population?
Well, for one, they'll be a lot younger.
Yep, age, so my sample is going to be systematically younger than the population. What else?
Possibly SES.
SES, right? Exactly. People with more means tend to be able to go to college, whereas people who don't, right? All sorts of stuff. So probably you could hypothesize general aptitude intelligence, right? Ethnicity, right? We're going to be underrepresented in a lot of ways, and so our sampling error is going to be huge, right? And so this is where we start to run into the interface of methods and statistics, right? If my methods are poor, my statistics are going to be suspect no matter what type of fancy corrections I'm doing with stuff, right? So think about your sample size, sample selection, and your measurement tool. Why is your measurement tool important? What do you think, Stephanie?
We want to make sure that it's bounded, it's measuring what it's supposed to be measuring. So that-
Absolutely. Couldn't have said it better, right? If my I'm interested in, say I'm a health researcher and I'm interested in the weight and or sort of mass of people in the US population, right? And so I invite people to my study and I go over and I grab them by the waist. How about this, right? I'm going to be way off. My measurement tool is going to be all over the place, right? Whereas if I put them on a physical scale that measures their mass and things like that, then I'm going to be much better, right? Same thing. And again, this is, we just had a discussion in a comps defense about this idea of employment, right? I'm going to measure employment. And what I do is I measure whether or not this person is earning money for a job of any type or they're not, right? That's a pretty rough gauge of employment, right? It's what I've measured, but whether or not my numbers actually reflect anything meaningful that I'm trying to capture within the population is going to be very different, right? And so thinking about when we're choosing tools to try and reduce our measurement error, or excuse me, our sampling error, wanting to get tools that are reliable, that are valid, and this is why when we're putting projects together, it starts to make sense to go through and investigate, saying, am I using best practice methods of assessing whatever it is that I'm trying to assess. So, again, methodology, huge component of the precision of your data. This is stuff that we can't fix with fancy statistics, right? If you bungle the design and the measurement, and you've got RAs that aren't trained up well and are doing kind of their own thing, who knows what we've got in terms of your data. It's going to be a hodgepodge of it's tough to know what, right? So always be mindful of your methodology. The more time and effort you put into researching this, you're just increasing the likelihood that your analyses are going to turn out. Okay. What is sampling error? I'll pick on Angeline.
The difference between your population parameters and your sample statistics.
Drive that into your brains. It's possible I might ask you that at some point in the future down the road. So, again, don't make it more complicated. And what people do back, oh, it means you have a crusty sample. No, it just means that that's something that always happens. These are the types of things that you can start to crank that down and make sure that you're reducing that to the best of your ability. Okay. Theoretical constructs. Hypothetical construct are going to be some sort of characteristic that aren't directly observed, but that are useful for describing, explaining some type of behavior. Someone give me an example of a construct. Lauren, give me an example of a construct.
I can't think of one off the top.
Literally say anything.
I did.
Right? Someone help her out on a construct? What's that?
Depression.
Depression is a construct. Like, I can't grab depression and wrestle it down to the ground, right? I can't pick it up and weigh it. I can't show it to you and say this is depression. Depression is a hypothetical construct. It's something, it's a collection of characteristics that we as psychologists have found useful for describing the behavior or way some people are, but it's not a real thing that I can grab and show you, right? Someone else give me another construct.
Stigma.
Stigma is a construct, right? It's something that we see in the way people behave, and we've said, okay, these sort of characteristics kind of hold together and sort of form this thing that we are thinking about in terms of stigma. But it's a hypothetical. It's not a real thing that I can grab, right? The best thing I can do is I can measure that through some sort of observable behavior, right? But again, this starts to become difficult because depending on my measurement or sort of differences in my conceptualization of this construct, we might get very different results based on whatever our targeted research question is, right? So things like aggression, personality, extroversion, trauma, right? What I consider trauma and not trauma differs a great deal from what other people might consider to be trauma and not trauma, right? If we're working with physical, things like height and mass are constructs, right? They're just constructs we're able to measure more precisely than our hypothetical psychological constructs. And this is where our operational definitions come into play.
So if we have
Yeah.
some kind of skills, does that come under the construct? So some kind of programming skill or something like that, if, does that comes under the construct or not?
Exactly, right? And so this is where we have to say, and hopefully we get some level of agreement where we can, and so in a clinical realm, right? If I'm talking about post-traumatic stress disorder, right? Probably what I'm talking about is what our American Psychiatric Association has identified as symptoms of post-traumatic stress disorder, right? And whether I agree with all aspects of that or not, for communication purposes, if I'm going to say this is post-traumatic stress disorder, I'm probably going to be working within that definition. But maybe not. Maybe I say my conceptualization or theoretical approach to this is something very different, and maybe it doesn't contain all the symptoms that are in the DSM, or maybe it contains symptoms that aren't in the DSM, right? And this is where your operational definition comes in, right? This is where you start to outline explicitly the rules for determining the presence or absence of whatever it is that I'm interested in, right? So if I'm interested, if my hypothetical construct is depression, I'm saying these are all the things that indicate depression. This is how depression differs from other things, say sadness, just general mood, right? Because we would say, in general as clinicians, that depression is a different thing than sadness. Sadness is part of it, but it's a different construct, right? So these are the rules for how we're determining whether or not this thing is present or absent, right? Aggression is a great example, right? If we say, does anybody not understand what aggression is? Everybody understands what aggression is, but we would probably individually come up with very different definitions of what aggression is. And if I sent you down all in a schoolyard and watched kids playing, we might come up with very different, and likely would come up with very different ratings on whether or not the level of aggression going on in that play, right? I might see kids playing football and be like, oh, that's part of football. Someone else might say that's all aggression, very high levels of aggression, right? And so unless we're all on the same page in terms of what the rules are, what the construct is, right? Because it's not physical. We can't, it's not just obvious, right? We have to lay out the rules in our research in terms of what we're determining, what we're calling sort of construct and what doesn't, right? And again, from my research area, defining trauma is a very tricky thing, right? Let's say your grandmother passed away. Is that traumatic, right? That's a touchy thing. I would say definitely it's stressful, right? But within the confines of trauma research, whether or not that constitutes trauma or not is going to be, we're going to have a discussion on where the boundaries are for what this is and what this isn't. Yeah.
So in that field, are there like set definitions, or everyone disagrees?
I wouldn't say everybody disagrees, but you get different camps of people. But it starts to make a difference, right? Because if I go through and I get a sample of undergraduates and I say 98% of my undergraduates have experienced a significant trauma, I'm probably going to say, we want to go through but then I start to question sort of whatever that data is and the results and things like that, because I probably don't agree with how they've defined and operationalized trauma, right? So as an example, in terms of operational definition, these are essential for our statistical inferences, right? If you say, here are my scores from a PTSD checklist that I collected from 98% of my undergraduates who endorsed a significant trauma, I don't know. Now, if you said, here's a group of individuals who have experienced sexual assault, and here are symptoms in response to that sexual assault, I'm probably going to be on the same page with you on that, right? I sort of am going to interpret those scores as something that approximates my conceptualization of post-traumatic stress disorder. But if you give a PTSD checklist to a random sample of undergraduates and 98% of them or 100% of them just fill it out, I don't know. Like, I don't know how to interpret that, because some of that is going to be trauma symptoms. Some of it's just going to be just general negative, like stressful things that happen to me, right? And if you ask people what stressful things happen to you, you may get the boundaries of severe physical assault, and I failed an exam last week, right? Which to me are kind of different things, but not that a person that failed an exam is totally, that's not a stressful thing. It certainly is. It's just not what I'm talking about, right? Again, as an example, so I'm doing some research with people who've been involved in serious motor vehicle trauma, right? And so what we found working with these people is that people do, when they're anxious in a car, they start to do strange things in the name of not getting in another accident, which might actually put them at greater risk of getting in an accident, right? So I'm scared to be in the car, and so I'm driving way on the shoulder, right? Or I'm driving 30 miles below the speed limit on the interstate, or I refuse to pass anybody because I don't want to get in an accident, or it's a green light in an intersection, but I slow way down and stop at the green light before I proceed through the intersection. I'm probably trying to make myself safe, but probably what I'm doing is actually putting myself at greater risk because I'm doing things that are deviating from the norms of general traffic stuff, right? So we thought this is an interesting thing. We want to measure this anxious driving behavior, but what we need to do first is we need to create an operationalization of what this is, right? And so for a study we run, said for the purpose of this research, anxious driving behavior is conceptualized as an excessive increase, decrease, or disorganization of behavior occurring as a consequence of anxiety during the operation of a motor vehicle. These behaviors of interest may be or but not necessarily reckless, inappropriate, or dangerous, right? And so these are the rules, right? So if someone is, without this operationalization, someone could be in the back seat not driving, and every time the car drives by, right? Like grabbing someone in the front seat, stuff like that. Now, is that anxious driving behavior? Well, they're not driving, so do we not count that, or do we count that, right? And so these are the types of things you want to think about. What are the boundaries for the construct that we're trying to capture, and then let's put together an operational definition to try and capture that, right? So again, this is an important thing because we're running statistical analyses on numbers, right? But our numbers are only as good as our constructs, right? And so if I don't have a good conceptualization of trauma, and I just ask people if they've experienced something stressful in their life, 100% of people are going to say, yes, I've experienced something stressful in my life because I'm a human being living on this planet. That's fine, I may have gotten stressed, but I don't know how to interpret these numbers because I don't know the extent to which these numbers map onto sort of the theoretical construct I'm interested in, right? And this is always important as you're evaluating research. The numbers are not the construct. The numbers are just a representation of this other thing that we're trying to capture. And we just do it to the best of our ability, but our measures are imperfect indicators of our actual theoretical construct we're interested in. It's easy to forget that as we're running analyses and be like, oh, this number is different from this number. That means that in the world that people are higher on this than that. Well, let's take a step back, think about how they captured that, how they measured it, and whether or not we can make any sort of reasonable inference on whether or not these things are different or not. Okay. Questions on any of this? All right. We'll finish out with different levels of measurement. This starts to become important in determining what types of analyses we're going to choose. Okay? If we're talking about our different types of variables, discrete variable, these are going to be variables that are made up of separate indivisible categories. If we're working with a discrete variable, no value exists between neighboring things, right? So numbers on the dice, right? Like I can't get a 6.5 for numbers. I can't get a 6.5. I can't get a 3.5. If I roll the dice, it's either 3 or it's 4. It's not 3.5. Like it just is one or the other, right? Same thing, number of children. Back, 2.5 kids. There's no such thing as a 0.5 kid, right? Like what we've done there is we've run a mean on a discrete variable, and that gives us a value that doesn't make any sense in real life, right? And so this is important why we start thinking about these. So discrete variables, these are things where there's no way to divide adjacent categories. Different than our continuous variables, these are variables that have an infinite number of values. Depending on the precision of my instrument, I can continually go down through to the 10th decimal place and start to determine the discrepancy between X and Y, right? Infinite number of parts, time, mass, temperature, right? Length, distance, right? With our standard measures of distance, I grab a tape measure, and I can measure the distance between Candace and I can keep getting more and more and more precise down to the distance between sort of electrons, atoms, and things like that, right? But sort of this idea of length and distance is a continuous variable. I can get down and keep chopping that in infinitely small sections. We can't do that with a discrete variable, okay? Questions about discrete continuous variables? Okay, so this is fine. Dichotomy in actual practice, we start to get a little, we play a little fast and loose between discrete and continuous. Okay? If we're talking about levels of measurement, at the very bottom level, in terms of our level of measurement, we have our nominal scales. These are sets of categories with different names. Okay, key feature of a nominal variable is there's no, we have labels for these different categories, and we can categorize them, but there's no natural order to this stuff, right? One's not necessarily in front or behind another. They are just what they are. Our nominal variables are distinct, but there's no information regarding direction or magnitude of difference. Someone give me an example of a nominal variable.
The numbers for football players.
Numbers. Yeah, no, that's a good example, right? They just are, right? We can say these numbers indicate quarterbacks and these numbers indicate receivers and things along those lines, right? But it's not, there's not, they don't mean anything, right? That's actually a tricky example. That's good, right? Someone else give me an example of a nominal variable.
Color.
What's that?
Color.
I'm sorry, one more time?
Color.
Color, right? Color is that like red's not different than blue, that's not different than green, right? Well, I mean, they are, yeah, but it's not like one goes in front of the other in terms of things, right? What else? Gender, right? What else? Brand, right? I mean, sort of this is a Toyota and that is a Ford. They're different, but there's not necessarily an order to them, right? And so these are our nominal variables. Ordinal scale, right? These are sets of categories, but a key feature of an ordinal scale is we've got a meaningful sequence, okay? We are ordering these in terms of size, magnitude, but the important thing to remember is there's inherent direction here, but no standardized magnitude. The differences between values are not necessarily equal. They might be, but they're often not. Can someone give me an example of an ordinal variable? Jim?
Like if you look at a deck, there's like king, queen.
What's that?
If you look at a deck, there's like king, queen, ace, and like poker.
Okay.
There are different like.
Yeah. Yeah, I think that's fair. I think that's fair, right? I mean, you can say this one's better than this one, better than this one, but in terms of maybe depending on the game, there's power in terms of stuff, right? Unless you're using actual numbers, start to get difficult in terms of sort of objective differences between things, right? Okay. What else?
Can we say the student ID that we get assigned as an ordinal scale or not?
I might have a problem with that just because, I mean, it's a number and numbers are one higher than the next, but it's...
But if that number is categorized based upon the year the students are enrolled in the university, will that be ordinal scale or not?
That one's tricky because again, like the idea is that we would want that number to be used as a measure of some construct, right? And so I don't know what the construct would be that we would want to try and distinguish, use the university number to distinguish a construct. I mean, if we had a prefix that had fall of 2017 and then, but how about just semester, right? Semester has an order, right?
Mm-hmm.
Spring of 2016 comes before fall of 2016, comes before spring of 2017. But the distance in terms of those, in terms of like weeks, is not the same, and it varies and things along those lines. So yeah, I think that would be an ordinal scale. Things like class rank, right? Like if we're just looking at, if at the end of this semester we order people in terms of who performed best and who performed lowest, I mean, 1, 2, 3 based on performance and grades and things like that, but that ranking system in and of itself, we might have someone who are first and second, like right on top of each other, differing from like in terms of a fraction of a point versus the next person down, you know, is 5 points, and then the person who had after 3. So that type of ranking system would fall under an ordinal scale. Our self-report scales, right? I go through and ask you all how happy you are right now on a 0 to 100 scale. I'm going to get all sorts of different variables or different answers, but Angeline's 20. Maybe a very different value in terms of her actual sort of objective construct than Lauren's 20, right? Alex is 25, maybe not the same distance as Katie's 15, right? Like it's going to be an order, like we say, we pretend it's continuous, but it's actually any of our Likert type scales or any type of self-report scale, almost always probably ordinal if we're thinking about that in terms of how it relates to the actual construct, because that's what's important, right? I can say, oh, you can write any value you would like on that scale. You could put down, you know, 37 7/4. You know, that would be, if someone was being really tricky, right? But that doesn't, and so it's a very precise number, but it doesn't actually fall along something that we would call an interval scale, right? Our interval scales, ordered categories, exactly the same units in size between the intervals. Distance between all intervals are equal. But the thing that makes the interval scale different is that we have a 0 point that's functionally arbitrary, okay? Example of our interval scale going to be things like temperature, right? 0 does not indicate, on a Fahrenheit scale, does not indicate the absence of temperature. It just means 0 is just an arbitrary point on the scale. Now, if we're working in physics with 0 degrees, like on a Kelvin scale, then that means all atomic movement is stopped, and so then that would be our next type. But in general, temperature in terms of Fahrenheit, Celsius, this is going to be an interval scale. SAT scores, IQ scores, right? 0 on an IQ score does not mean the absence of intelligence. It just means something went terribly awry in terms of administration. Same thing. 0 on an SAT doesn't indicate the absence of achievement, right? The difference between a 10 and a 15 is the same as the distance between a 15 and a 20, but it's not, that 0 point doesn't indicate the absence of a construct. Ratio scale, this is going to be an interval scale with an absolute 0. Okay? So things like height, right? If my height is 0, it means that I have no height. If my mass is 0, it means there is no mass. Speed, if I'm moving at 0 miles an hour, it means I am not moving forward at all, right? Income, if I'm making $0, it means I have functionally 0 income, right? And the difference between my income of $1,000 a year and $2,000 a year is the same difference in terms of the scale that we're using, right? And so what we have with our variable types are discrete variables. These are nominal and ordinal. Our continuous variables are interval and ratio. Asterisk beside the ordinal, because we often treat our ordinal variables not as discrete but as continuous, right? We say if we've got an ordinal variable with, you know, 5 or more categories, statistically we can treat that as a continuous variable, and oftentimes that's the case depending on the distribution of that, not always, right? But in terms of thinking about a lot of our scales that we use in psychological science, these are ordinal scales by definition, even if we're using them in a continuous fashion. Questions? All right. And this starts to become important because variable type level of measurement is going to determine what analytic approach we use. This is one of the things that students often find difficult. They say, oh, this is my research question. What analysis am I going to use? First thing you need to do is say, what are my independent variable? What are my dependent variable? What's the level of measurement? You answer those 2 questions, and your approach is going to be narrowed down quite a bit. notation, mathematical variables, variables X, Y, Z, cases, subscripts. So this is person 1, person 2, person 3, down to person I. Variables, this is condition 1, condition 2, condition K, or whatever the condition is. People in the population, individuals in the sample. There's sigma, sigma. Anybody terrified of sigma? Some of you rely on me, because I know some of you are terrified of sigma. This just means adding up everything after that, right? Final thoughts, okay? Statistics not a cut and dry set of facts, right? A set of facts put together a variety of interpretations and opinions. This is something that we're going to work on continuously throughout this semester, forcing you all to think about what am I doing, why am I doing it, what are my alternatives, what are the pros and cons, and what does this mean in terms of my interpretation, right? Whoops. No, that's another. But before we get to the joke slide. So you can't fix analyses that you bungled by design, right? Thinking about, like, we're going to focus on the analyses here, but always be thinking in the back of your mind the design, right? I'm going to give you problem sets, right? I'm going to say this is what we did. If you want to say, well, fine, these are the analyses we ran, but this is why we can't actually infer anything from that because you employed a crappy design. Cool. Tell me about that. Shows me that you're thinking about measurement issues. This is my friend who's an accounting professor told me once that there are statistics, we're not their people, right? You're in charge, right? You drive the statistics, what you're doing. You are not a passive recipient of information and numbers, right? Wanting to go through, be effective in choosing your designs, how you're going forward and interpreting that stuff. And I'm never going to ask you to do 100%. All right, questions on any of this? 5 o'clock, look at that, like right dead center, right? This is how good, this is after so many semesters, this is the precision at which I've sort of timed this down. We'll just be up there a little bit towards the end. Cool, all right, hey, thank you everybody.